The distance between a UPS, or uninterruptible power supply, and the overcurrent protection device located outside of it should not exceed 10 feet. This requirement stems from the National Electrical Code, specifically addressing single-phase feeder taps. The 2020 National Electrical Code mandates that for single-phase feeder tap, the distance from the power source, which in this case is the UPS, to the overcurrent protection device cannot be greater than 10 feet. The primary reason for this 10-foot rule is to ensure rapid fault clearing. If a fault occurs on the feeder tap, it's crucial that the overcurrent protection device activates quickly. This swift action prevents damage to the equipment and minimizes the risk of electrical hazards. The 10-foot distance is measured from the point where the feeder tap connects to the UPS output to the point where it connects to the overcurrent protection device. It is a linear measurement. If the distance between the UPS output and the overcurrent protection exceeds 10 feet, then additional overcurrent protection might be needed. This additional protection would be installed closer to the UPS output to comply with the code and ensure adequate fault protection. The overcurrent protection device must be appropriately sized for the load it is protecting. This involves calculating the current draw of the equipment being powered by the UPS and selecting an overcurrent protection device with a suitable amperage rating. Selecting the correct overcurrent protection device is crucial. An undersized device may trip unnecessarily, interrupting power to the load, while an oversized device may not trip quickly enough to protect the equipment in the event of a fault. It is important to consult the specific UPS manufacturer's instructions for any additional guidelines or recommendations related to overcurrent protection. Manufacturers often provide detailed information on the types and sizes of overcurrent protection devices that are suitable for the UPS models. This information can help ensure compliance with both the NEC and the manufacturer's specifications. In summary, the 10-foot rule for single-phase feeder taps connecting a UPS to an overcurrent protection device is a critical safety measure. It ensures that faults are cleared quickly, protecting equipment and preventing electrical hazards. Always adhere to the NEC guidelines, consult the UPS manufacturer's instructions, and ensure that the overcurrent protection device is properly sized for the load. Let's delve deeper into some related electrical concepts. First, let's talk about overcurrent. Overcurrent refers to any current exceeding the rated current of equipment or conductors. It can be caused by a variety of factors, including short circuits, ground faults, and overloads. Short circuits occur when there is an unintended low resistance path for current to flow, such as when a hot wire comes into contact with a neutral wire or a ground wire. Ground faults occur when a hot wire comes into contact with a grounded surface, such as a metal enclosure. Overloads occur when equipment is drawing more current than it is designed to handle. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when an overcurrent condition occurs. This protects equipment and personnel from damage and injury. Circuit breakers are electromechanical devices that trip open when an overcurrent is detected. They can be reset after they trip, allowing power to be restored. Fuses are one-time use devices that melt and open the circuit when an overcurrent is detected. They must be replaced after they blow. The selection of the appropriate overcurrent protection device depends on several factors, including the voltage and current rating of the circuit, the type of load being protected, and the interrupting rating of the device. The interrupting rating is the maximum amount of current that the device can safely interrupt. It is important to select a device with an interrupting rating that is greater than the available fault current at the point of installation. Now let's consider feeder taps. A feeder tap is a conductor that is connected to a feeder conductor to supply power to a load. Feeder taps are often used to supply power to individual pieces of equipment or to small subpanels. The NEC specifies requirements for the length and size of feeder taps. These requirements are intended to ensure that the taps are adequately protected from overcurrent and that they do not create a fire hazard. The 10-foot tap rule is one of these requirements. It applies to taps that are no longer than 10 feet and that are protected by an overcurrent protection device that is rated at not more than 300% of the ampacity of the tap conductors. The ampacity of a conductor is the maximum amount of current that it can safely carry. The ampacity of a conductor depends on its size, material, and insulation type. The NEC provides tables that list the ampacities of various types of conductors. In addition to the 10-foot tap rule, the NEC also allows for longer taps under certain conditions. For example, a tap can be up to 25 feet long if it is installed in a high bay manufacturing facility and is at least 30 feet above the floor. However, these longer taps must meet more stringent requirements than the 10-foot taps. When installing a UPS and its associated overcurrent protection, it's important to consider the following. Firstly, ensure that the UPS is properly sized for the load it will be supporting. Secondly, select an overcurrent protection device that is appropriately sized for the load and that meets the requirements of the NEC and the UPS manufacturer. Thirdly, install the overcurrent protection device within 10 feet of the UPS output unless otherwise permitted by the NEC. Fourthly, use conductors that are of the correct size and type for the application. Fifthly, properly terminate all connections. Sixthly, test the installation to ensure that it is working properly. In addition to the NEC, there may be other applicable codes and standards that must be followed. For example, the International Building Code and the International Fire Code may have requirements for the installation of UPS systems. It is important to consult with a qualified electrical engineer or electrician to ensure that the installation complies with all applicable codes and standards. Some additional points to remember are: firstly, always disconnect power before working on any electrical equipment. Secondly, wear appropriate personal protective equipment, such as safety glasses and gloves. Thirdly, use properly insulated tools. Fourthly, never work alone. Fifthly, if you are not qualified to perform electrical work, hire a qualified electrician. EPS systems are an important part of many critical power systems. They provide backup power in the event of a power outage, which can prevent data loss, equipment damage, and other disruptions. However, UPS systems can also be a source of electrical hazards if they are not properly installed and maintained. I follow in the guidelines in this discussion, and consulting with qualified professionals, one can help ensure that a UPS system is installed safely and reliably. Now, let's elaborate on the practical implications of exceeding the 10-foot limit. Imagine a scenario where the UPS is located in the server room and the distribution panel it feeds is in an adjacent office, a distance of 15 feet. Without additional overcurrent protection closer to the UPS, a short circuit in the wiring between the UPS and the panel could result in a significant fault current flowing for a longer duration. This extended fault current could overheat the conductors, potentially leading to insulation damage, fire, and equipment failure. The 10-foot rule is designed to mitigate this risk by ensuring that the overcurrent protection device trips quickly, limiting the amount of energy released during a fault. The requirement for appropriate sizing of the overcurrent protection device is equally crucial. If the device is too large, it may not trip quickly enough to protect the conductors and equipment. If it is too small, it may trip unnecessarily due to normal load fluctuations. The ideal size is one that provides adequate protection without causing nuisance tripping. This often involves a careful analysis of the load characteristics and the inrush current requirements of the connected equipment. Furthermore, it's important to consider the voltage drop along the feeder tap. Excessive voltage drop can negatively impact the performance of the connected equipment, causing it to operate inefficiently or even malfunction. The length and size of the conductors, as well as the load current, all contribute to voltage drop. The NEC provides guidelines for calculating voltage drop and for selecting conductors that minimize it. Proper grounding is another essential aspect of UPS and overcurrent protection system design. A properly grounded system provides a low impedance path for fault current to flow back to the source, which helps to ensure that overcurrent protection devices trip quickly. The NEC specifies requirements for grounding electrode systems, grounding conductors, and bonding. Failure to properly ground a system can increase the risk of electrical shock and equipment damage. In addition to the NEC, other standards and guidelines may be relevant depending on the specific application. For example, healthcare facilities may be subject to additional requirements related to emergency power systems in critical care areas. Industrial facilities may have specific requirements for hazardous locations and safety interlocks. It is important to be aware of all applicable codes and standards and to ensure that the installation complies with them. Regular inspection and maintenance are also crucial for ensuring the continued safe and reliable operation of a UPS and overcurrent protection system. This includes visually inspecting conductors and connections for signs of damage or deterioration, testing overcurrent protection devices to verify that they are operating correctly, and checking grounding connections to ensure that they are intact. Any deficiencies should be promptly corrected. Finally, it is always advisable to consult with a qualified electrical engineer or electrician when designing, installing, or maintaining a UPS and overcurrent protection system. These professionals have the knowledge and experience to ensure that the system is safe, reliable, and compliant with all applicable codes and standards. They can also provide valuable insights into the specific requirements of the application and recommend solutions that are tailored to the unique needs of the customer. The importance of proper installation and adherence to electrical codes cannot be overstated when dealing with UPS systems and overcurrent protection. The potential consequences of a faulty installation can range from equipment damage and downtime to serious injury or even death. Therefore, it is essential to approach these installations with the utmost care and attention to detail. Firstly, consider the environmental conditions in which the UPS and overcurrent protection devices will be operating. Extreme temperatures, humidity, and corrosive atmospheres can all negatively impact the performance and lifespan of electrical equipment. Select equipment that is rated for the specific environmental conditions and take steps to protect it from the elements. Secondly, pay close attention to the labeling and markings on electrical equipment. These markings provide important information about the voltage, current, and other ratings of the equipment. Always follow the manufacturer's instructions and never exceed the rated capacity of the equipment. Thirdly, use appropriate tools and equipment for the job. Working with electricity can be dangerous, and it is essential to use tools that are designed for the task. Use insulated tools to prevent electrical shock and wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, double-check all connections to ensure that they are tight and secure. Loose connections can cause overheating, arcing, and equipment failure. Use a torque wrench to tighten connections to the specified torque value. Fifthly, document all work that is performed. Keep accurate records of the equipment that is installed, the wiring diagrams, and the test results. This documentation will be helpful for future maintenance and troubleshooting. Sixthly, provide training to personnel who will be operating and maintaining the UPS and overcurrent protection system. Ensure that they understand the proper procedures for starting, stopping, and troubleshooting the equipment. Also, ensure that they are aware of the safety precautions that must be taken when working with electricity. Regular audits and inspections can help to identify potential problems before they lead to equipment failure or safety hazards. Conduct regular visual inspections of the equipment and perform periodic testing of the overcurrent protection devices. Also, review the maintenance records and identify any trends that may indicate a need for corrective action. The integration of smart technologies, such as remote monitoring and control systems, can further enhance the reliability and efficiency of UPS and overcurrent protection systems. These systems can provide real-time data on the status of the equipment, allowing for early detection of potential problems. They can also automate certain tasks, such as load shedding and generator starting, which can improve the overall performance of the system. The use of uninterruptible power supplies and the implementation of robust overcurrent protection measures are critical for ensuring the continued operation of essential equipment and systems. By following best practices and adhering to industry standards, businesses and organizations can minimize the risk of power outages and protect their valuable assets. The NEC provides a comprehensive set of guidelines for electrical installations, including those involving UPS systems and overcurrent protection. This code is updated every 3 years to reflect the latest technological advancements and safety concerns. It is important to stay up to date on the latest version of the NEC and to ensure that all electrical installations comply with its requirements. In conclusion, the 10-foot rule for single-phase feeder taps connecting a UPS to an overcurrent protection device is a crucial safety measure. It ensures that faults are cleared quickly, protecting equipment and preventing electrical hazards. Always adhere to the NEC guidelines, consult the UPS manufacturer's instructions, and ensure that the overcurrent protection device is properly sized for the load. This detailed discussion covers a wide range of related concepts and practical considerations, providing a comprehensive understanding of the importance of proper UPS and overcurrent protection system design, installation, and maintenance.